sklearnutilsclassweight. Description: the classweight function in scikit-learn sklearn is used to calculate weights for each class in a classification problem. These weights are used to balance the dataset when there is a significant class imbalance. Class imbalance occurs when one or more classes have significantly fewer instances compared to others. This imbalance can lead to biased model training, where the model favors the majority class and performs poorly on the minority class. Inputs: a1d array containing the target labels for the training data. Classweight: a string or dictionary specifying the class weights. Outputs: classweights: a dictionary mapping each class to its corresponding weight. Steps: if the classweight parameter is set to balanced, the function calculates class weights inversely proportional to the number of samples in each class. If a dictionary is provided, the function uses the weights specified in the dictionary. If the classweight parameter is not specified or set to none, all classes are assigned equal weights. Metrics: precision: the ratio of correctly predicted positive instances to the total number of predicted positive instances. Recall: the ratio of correctly predicted positive instances to the total number of actual positive instances. F1 score: the harmonic mean of precision and recall. Visualization plots. Confusion matrix: a visual representation of the model's performance, showing the number of correctly and incorrectly classified instances for each class. Precision recall curve: a plot showing the trade-off between precision and recall for different classification thresholds. Receiver operating characteristic ROC curve: a plot showing the true positive rate sensitivity against the false positive rate 1 specificity for different classification thresholds. Fine-tune parameters. Classweight: this parameter can be used to specify the class weights manually or to use the balanced option to automatically calculate weights. Uncertainty methods. Confidence intervals: estimating confidence intervals for the predicted probabilities can provide a measure of uncertainty. Bayesian methods: using Bayesian methods to model the data and incorporate prior information can capture uncertainty in the model parameters. Challenges and fixes. Challenge: 1 class imbalance can lead to biased model training, resulting in poor performance on the minority class. Sample use case that resulted in challenge 1: if fraud detection dataset where only a small percentage of transactions are fraudulent. Fixes to challenge 1: use the classweight parameter with the balanced option or specify custom weights to balance the dataset. Challenge 2: determining the optimal class weights can be challenging, as it depends on the specific dataset and the desired trade-off between precision and recall. Sample use case that resulted in challenge 2: a medical diagnosis dataset where different classes have different costs associated with misclassification. Fixes to challenge 2: experiment with different class weights and evaluate the model performance using appropriate metrics, such as F1 score, to find the best balance.